equal to log of base 7 of x. So log of base 7 of x equal to log base 7 of 4. So here base is same, so we can compare argument on both sides. So here value of x is 4. Now we will discuss on presentation. This can be written as log base 7 of x equal to log base 7 of 8 raised to 2 by 3. That will be x equal to 8 raised to 2 by 3, and that you can simplify as cube root of 8 is 2 raised to 2, 8 raised to 2 by 3 is nothing but 4. So value of x is 4. Next example. Solve 4 log base 8 of x equal to log base 8 of 81. This example we will discuss on table. Question is 4 log base 8 of x equal to log base 8 of 81. So on left hand side we will apply power property of logarithm. Log base 8 of x raised to 4 equal to log base 8 of 81. Now we will apply equality property on both sides. As base is same, so we can simply equate argument. That can be written as x raised to 4 equal to 81. So value of x is plus or minus 3. So here we have to consider x equal to 3. X equal to minus 3 is not possible here, as argument must be positive according to the definition of log. Now we will discuss on presentation. That can be written as log base 8 of x raised to 4 equal to log base 8 of 81. So that can be written as x raised to 4 equal to 81. So x equal to plus or minus 4th root of 81, and that is plus or minus 3. So the only solution is 3, as log of base 8 of minus 3 is not defined. Log base 5 of x minus 2 plus log base 5 of x plus 12 equal to 2. Here we want to find value of x. We will discuss on table. What is the question? Question is log base 5 of x minus 12 plus log base 5 of x plus 12 equal to 2. On left hand side we will apply property of logarithm. Addition goes to multiplication. Log base 5 of x minus 12 into x plus 12 equal to 2. As addition goes to multiplication, log base 5, that we can simplify as x square minus 12 square, that is 144 equal to 2. To find value of x, we will use definition of logarithm and we will convert into exponential form. That will be 5 square equal to x square minus 144. So 25 equal to x square minus 144. So x square equal to 169. So x equal to plus or minus 13. Here x equal to 13 we will consider, as x equal to minus 13 is not possible, as argument must be positive. Now we will discuss on presentation. First we can apply product, addition goes to multiplication, that is log base 5 of x minus 12 into x plus 12 equal to 2. That will be 5 square equal to x minus 12 into x plus 12. That will be 25 equal to x square minus 144. That is x square minus 169 equal to 0. So value of x is either 13 or minus 13. Now try some examples for yourself. Log base 10 of x equal to 1 by 2, log base 10 of 81. Second example is log base 6 of x equal to 3 by 2, log base 6 of 9 plus log base 6 of 2. Third example is log base 7 of 3x plus 5 minus log base 7 of x minus 5 equal to log base 7 of 8. And you can note down all the three questions. Answers are given. Answer of first example is 9, answer of second example is 54, and answer of third example is 9. Change of base formula. Let us see what is the change of base formula. Let a, b and x be a positive real numbers such that a is not equal to 1 and b is not equal to 1. Then log x to the base a can be converted to a different base using any of the following formulas. These three are different form of change of base formula. First, log base a of x can be written as log base b of x by log base b of a. Means log term x is in numerator and base is in denominator with any base according to the question. So log base a of x can be written as log x by log a. Similarly, that can be written with base 10, that is log x by log a, and the same can be written with base e, ln x by ln a. Now we will discuss some example based on the properties of logarithm on table. Right, first question. Log base 3 of 27. Here we want to find this value. So this can be written as log base 3 of 3 cube. 27 can be written as, apply power properties. So this will be 3 of log base 3 of 3. And log a to the base a is 1. So answer is 3. Let us see next example. Log of 343 of base 7. Here we will apply property of change of base formula. So this we can write it as log 7 by log 344 according to the property of change of base formula. Here base we have not written yet. According to the question we will use base 7. As we know that log a to the base a is 1. So 1 by log base 7 of 343. And 343 can be written as power of 7. That is 1 by log base 7 of 7 cube. And in denominator we will apply property of logarithm, property of power, and 3 will come forward. So 3 of log base 7 of 7, and log a to the base a is 1. So answer is 1 by 3. Let us see next example. Log base a of 125 divided by log base a of root 5. we want to find this value. So this can be written as log base a of 1 by 25 by log base a of root 5, and 125 can be written as root 5 raised to 6 over log base a of root 5. So this is nothing but 6 of log root 5 over log base a of root 5 with base a. That term will be cancelled out. So answer is 6. Now we will discuss on presentation. Now I will show you one video based on the discussion what we have discussed so far.
With an introduction to quantitative finance, a continuation in that series. Here today, a brief refresher or a brief tutorial that introduces logarithms. Logarithms are very important in quantitative finance. They are a key building block, so we don't want to gloss over them. We want to make sure we've got a firm grasp on logarithms. And so to do that, I put up here a basic logarithmic function, and we could read this as the log base 10 of 100 equals 2. How can we understand that? Well, we can look at the inverse of this logarithmic function. This is a logarithmic function right here. Its inverse is an exponential function. In this case, notice I have 3 numbers involved here on the top. I also have 3 in the bottom. 10 squared is equal to 100. That's more intuitive. Well, that helps to explain why the answer here is 2. 2 is the answer of this logarithmic function because 2 is what we need to raise the base, in this case 10, to the power. So 10 raised to what power? Well, the power 2 in order to get 100. So the base raised to the second power gets us the x value. So see how this exponential function, which is the inverse, is really just a restatement here of this logarithmic function. So that generically we can say log base a of x is equal to y because it's true that a raised to the y power is equal to x. So I'll go back to actual numbers now. I used this example, base 10. That's the number base we're comfortable with. There's nothing magic about that. Now I'm going to substitute in for 10 the natural e, which is an irrational number. It's equal to about 2.718, but it's irrational, so that goes on forever. Then now if I use instead of 10 the natural e of the base, the same rules about the logarithmic function apply. I've just changed the base, so I can still say the log base e of x is equal to y.
Okay friends, so today we had discussed about introduction of logarithm, history of logarithm and properties of logarithm. Next time we will discuss example based on logarithm. Thank you.